Okay, so in this problem we are faced with a rocket. This rocket goes up this ramp with an acceleration of 2 meters per second squared, and at the end of this ramp stops accelerating, which sends it into a parabolic motion. And we are asked, what distance does the rocket move until it lands in the horizontal plane? And to do this, we have to do a bunch of things. First of all, it's convenient to divide the motion in two parts. First, this part in which we have a simple kinematic motion, in which we have an acceleration in this distance. To calculate this, we have an initial velocity of 0 and an acceleration of 2 meters per second squared, as I mentioned earlier. So we can just simply substitute in this kinematic equation. So, since our initial velocity is 0, then we can cancel this term, and we only have to substitute the distance here, the acceleration, and we got our final speed squared, which is what we are asked, because we need to know this in order to know at which speed this is gonna start its parabolic motion, alright? So, what we do is we calculate this by substituting the following data, and we got that Vf squared equals 800 meters. So in order to get Vf squared, we have to simply get the square root of this, which equals to 28.28 meters per second. So as I mentioned earlier, it's the initial velocity of the parabolic motion. Once we have that, we need to get the time, because once we get the time, we can calculate everything else. So to do this, we have to have our equation for x and for y of the parabolic motion, because we divide it into two parts. So since we have a negative gravity, because we defined that up equals positive and right equals positive, then we get the following equation. First of all, before we go into this, it's important to note that our rocket won't leave its parabolic motion from this point. It's gonna start at this point, which is at a height. And to calculate this height, we have to use simple trigonometry. We know that the hypotenuse equals 200 meters and our angle 35 degrees. So by using 200 times the sine of 35, we know that this height equals 114.7 meters. So this is our initial height, which we will substitute in our y equation. So we got that our final height, which is 0 because it landed, equals our initial height 114.7 plus our initial speed times the sine of 35, because remember we're talking about a motion in y, times the time, minus, because we said gravity is facing downwards, 1/2 of gravity times time squared, which of course leaves us with a quadratic equation. This quadratic equation is conformed of minus 4.9t squared plus 16.2t plus 140.7, and these are our three terms, which will give us two values of time, of which we will take this one, 6.77. So once we got this, we can substitute this time in our x equation, which is the following: x final equals initial speed, initial velocity times time, because we cancel out all the other terms because we have a constant speed, alright? So by substituting this, we get a final x of 156.8 meters. Here's Kuko with a unibrow. Peace.